terminology of probability. So we are going to use set theory to discuss what is probabilities. So first we will talk about what is sample space, event, and classical probability. Definition: the set of all possible outcomes is called a sample space. Omega, this is a capital letter, this is a small letter, omega. So basically what is sample space? Just all the possible outcomes. So for example, you toss a coin. So what are the possible outcomes? Head and tail. If I toss a coin once, the sample space is head or tail. But if I toss a coin twice, you can have head, 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 tail, tail, head, tail, tail. And if I toss a coin thrice, 3 times, then you have all this. How many of them? 2 to the power 3, which is 8. How do you see this? Again, using the tree idea, you toss it 3 times. So the first one is a question mark, so you can have branches. The first branch is you have a head, and then you have a tail, and you can keep branching it 3 times, so 2 to the power 3. So anything that is a subset of this sample space, omega, we call it an event, and we label it as E. For example, if I toss 2 times and I get TT, so it will be an event. And basically, if I take the union of all the event, it will give me the sample space. And if I have an E, it will be a subset of the sample space. And what is the definition of probability? The classical probability, PE of an event E, this PE means probability of E. You write 2 vertical lines and then write a P. And then what's the definition of probability? The probability of an event E is basically the cardinality of the set E divided by the cardinality of the sample space. Okay? And since mathematics do not allow divide by 0, so we assume omega is non-empty. Although we just say that omega cannot be empty set, it does not mean E cannot be empty set. E can be empty set. Okay? Omega can also be an infinite set. Example, suppose I have a 4-sided die, and then I do 1d4. That means roll this 4-sided die once. What's the sample space? 1, 2, 3, 4. And let's say my event E is defined as less than or equal to 3. Less than or equal to 3, then what's the size of this E? You first identify what is E1. It's less than or equal to 3, that means 1, 2, 3. What's the sample space? 1, 2, 3, 4. Then the size will be 4. So you have 3 divided by 4. That means the probability of getting event 1 is 0.75. Let's say E2 is defined as even number. Then E2 is 2, 4. And the chance of getting E2, that means the probability of E2 is half. And let's say E3 is defined as larger than 0. Well, all the number in the dice, this outcome, are all larger than 0. So the chance is 1. That means you always get number larger than 0. The chance of getting output that is smaller than -2 is 0 because E4 is an empty set. 2d4, that means I roll this die twice. This will be the result. So let me recap. What is this? This is actually the Cartesian product. So 2d4 actually is 1d4 Cartesian product of the set 1d4. Or you can say that the omega of 2d4 is the omega of 1d4 Cartesian product with the omega of 1d4. And it gives you this. There are 16 elements. Suppose E5 is defined as all the output ij such that I plus j is larger than 6. So you first need to identify what are the ij's that is larger than 6. It will be 3, 3, 3, 4, 4, 3, and 4, 4. So how many of them? There are 4 of them. How many events are there? 16. So the chance, if you roll the 4-sided die twice, then what happens? You will have this chance of getting this. And let's say E6 is defined as ij such that I is smaller than j. So basically, what does it mean? It means all the result that the row is smaller than the column. The chance of getting this triangle within the 16. So the triangle have 1, 2, 3, 4, 5, 6, 6 of them. So it will be 6 divided by 16, which is this number. What about if ij such that I is j plus 1? So I is j plus 1, so you look for the number that satisfies this. For example, when I is 2, j has to be 1. So this one. When I is 3, j has to be 2. Okay? And I is 4, j is 3. Okay, so you have these 3 number. You only have 3 events out of this 16 event. So therefore, 3 divided by 16. And lastly, what about if I want ij such that I plus j is a prime number? Then you compute the sum and look for the result that is a prime number. You will count it. It will be 9/16.